So we've talked about rectifiers, which convert AC to DC, but most of our electronics need a really steady DC voltage source, and just with a rectifier you can't get that because the ripple, the little bit of the AC that's left over, you can control it with a capacitor, but you can't really eliminate it. So to get a pure DC voltage you need a regulator, and now that we know about Zener diodes we can see where that comes in. So you have some source of unregulated voltage, we'll call V sub S. That's probably from a rectifier, and so it has some ripple in it. And then we use a Zener diode, which has a very precise breakdown voltage, to be our reference voltage. And basically we just get the power from V sub S, but have the voltage set by the Zener diode. And then we get some output and we have a feedback loop that will always compare the output to the input using an op-amp. So there's a couple different varieties of this. So you can have it all on one chip, and the chips we use are the 7806 and 7906. The 6 here means 6 volts, 8 is positive, 9 is negative. Ours, remember, 9 starts with an N, as does negative. And they each have 3 pins, though you do need to be careful. The pins don't mean the same thing in the two. 7806 is different than 79, so you have to look it up. But there's 3 inputs: an input voltage, meaning the unregulated voltage, and the output voltage, which is the regulated voltage, which in this case is either plus or minus 6 volts, and a ground. What's regulated is the voltage between ground and the output. So all you have to do is put in your input voltage, which should be greater than plus 6 or less than minus 6, depending on what you need to get out, and the output will be plus or minus 6 volts. It's recommended that you put in some stabilizing capacitors between the inputs. That just helps with the high frequency ripples to get rid of those effects. Just put them in. We won't worry too much about exactly what they do. And that's as simple as that, as long as you want 6 volts, plus or minus. We also will be using a regulator called the 723, which is not really a regulator at all until you hook it up, and you have to hook it up yourself. And so it has a Zener diode in the reference voltage. That's part of the box. I just draw it up separately because you have to connect 2 pins. And so if you want to make an output voltage that's bigger than the reference, which is about 7.15 volts, you need to create an output that is compared to the input with a voltage divider. So all we do here is we have a voltage divider, an R1 and R2 to ground, R2, R1, and so we're going to get an output voltage here that's bigger than the input voltage, and that input voltage we compare to our reference voltage. We can put a third voltage in here, a third resistor in here, just to match the impedance, in which case R3 should be the value of R1 and R2 in parallel, so that this impedance equals the output impedance of this. Now we do have to hook up a few other things. The 723 has a current limiting input. And what we do is we put a small resistor here called R4, and we connect it this way through this transistor. And what happens is if we draw a lot of current here, and we should connect, so the power comes from here. So if we draw a lot of current through here, too much, then the current source will, this voltage drop will cut off this part, and we won't be able to put out too much current. The recommended value for R4 is that the voltage drop here should be half a volt at the full current that you want to, the largest current you want to be putting out. So the only final thing we have to do to connect it here is you have to put in the unregulated voltage here. So this is our V in, and we use it both as the power for the op amp and as the source of the current. The current will come out through this way. And then we just need to put a stabilizing capacitor in here, which should be about 100 picofarads. And so, again, this will be the regulated voltage V out, which is just, you take some fraction of that, compare it to the reference voltage, which is 7.15 volts. And so that's how you make the case where V out is bigger than 7.15. Now, if we want to make the output less than 7.15, we just have to move the voltage divider. So we put the voltage divider here now. So here's R2 and R1, and we put that on the input, and now we compare our output voltage to that reference. And again, we put a small resistor here to limit the current. Again, this R4 should be such that it limits the overall current, so that R4, the voltage drop across R4 will be half a volt at full current. And we connect the V out. That way, it's often recommended that between V out, at V out we connect a capacitor to ground to stabilize things at high energy. And so this can be, or high frequency, that should be about 10 microfarad. And again, we put in a capacitor here of 100 picofarad. So the key again is that we're now comparing the output to this input. The input is the result of a voltage divider rather than the output side. So we can make the reference smaller and then compare a smaller value to that. We can only go down to about 2 volts. In both these cases, we need the input. Oh, forgot to draw the input here. This needs to be several volts above 7 volts, or in the case where we're making it much larger than 7, this needs to be several volts higher than the output.